All right, I'm Nathan Aycock. This is Nick, Cody, and Marvin. We are the Hopper group for the MED design project. For that, we did the cutaway four-stroke engine for Dr. Rowe's internal combustion engine class. To start off, we had to talk to Dr. Rowe, get some requirements, and through those requirements, we built a prototype. Once we built the prototype, we had to go back to Dr. Rowe, see what he liked, see what he didn't like. And through that, he said he wanted a chain and sprocket for the back, just to make things easier, to help with variable valve timing, and also to prevent, well, originally the prototype just had goofy big Mickey Mouse ears, along with the fact that it looked like a birdhouse. And then he also wanted to see the valves move up and down, so for that we used a clear plastic head. And also, to go back to the variable valve timing, he used that to, maybe if you want to talk about a different stroke or an economical engine, he could easily do that. And to go into a little bit more depth about how it works in action, I'm going to hand it over to Nick.
Okie dokie. So, basically, you move your crankshaft and power is transmitted through the chain, through these sprockets and sprockets to the cams, which will actuate the valves. This one's intake, that one's exhaust. I'm going to demonstrate. So this is the intake stroke, because the cam's pushing the intake valve down. And you got the compression, where they're both closed. Combustion, where the spark plug ignites. And exhaust. And if Dr. Rowe ever feels the need to, he can change the valve timing just by sticking a hex key in these sprockets and letting out a little bit, and then these cams can move independently of the shaft, so he could set it to whatever he wanted if he wanted to talk different types of cam profiles, or the cams are easily interchangeable if he wanted to do that too. And I'll talk to you about the testing.
Alright, for the testing, our initial was to keep it light, make it portable, and carry it to class, back to his office easily. So we want to keep something light, which shows 8 pounds. It ended up being around 6 pounds, which was good. And then our next test, our initial test, was to make sure it turned quickly without anything breaking on it. And if something had broke, we would have done more testing on the parts that broke. But on the initial test of just turning it, make sure nothing broke, we chose about 100 RPMs, and we successfully turned it with nothing breaking. And so we didn't need to do anything more in depth than that. And for the cost analysis, Marvin will take over.
For the final product, we had to buy the chains, the gears, valve springs, the head, and the case from McMaster-Carr. It was around $152, and the cost labor was around $15, and we spent 2 hours working on it. So the product, the final product cost around $182.64.